Today we'll be solving this integral, the double integral from x equals 0 to 1, and for each x, y goes from e to the x power up to e of dxd y divided by log y. First, let's understand the region of integration. In our original integral, x ranges from 0 to 1, and for each value of x, y ranges from e to the x power up to e. Let's visualize this region in the xy plane. Let's describe this region algebraically. The region is bounded by x equals 0, x equals 1, and the curves y equals e to the x, and y equals e. We can express this using inequalities x is between 0 and 1, and y is between e to the x and e. To change the order of integration, we need to express the region differently. Instead of thinking about x first, and then y, we'll think about y first, and then x. For each fixed value of y, what are the possible values of x? From y equals e to the x, we can take the natural logarithm of both sides to get x equals log y. This gives us the constraint that x is less than or equal to log y. Now, we need to determine the new limits of integration. For y, the lower limit is the minimum value of y in the region, which is y equals 1 when x equals 0. The upper limit remains y equals e. For x, with a fixed value of y, x ranges from 0 to log y, but only up to 1, since that's our original upper limit for x. So for each y between 1 and e, x goes from 0 to the minimum of log y and 1. But since log of 1 is 0 and log of e is 1, in our region log y is always less than or equal to 1. So x simply goes from 0 to log y. Now we can rewrite our integral with the new order of integration. We have the double integral from y equals 1 to e, and for each y, x goes from 0 to log y of the same integrand dxd, y divided by log y. Let's evaluate the inner integral first. We integrate with respect to x, treating y and log y as constants. So integrating 1 over log y with respect to x from 0 to log y, we get x divided by log y evaluated from 0 to log y. This equals log y divided by log y, which simplifies to just 1. Now, we can evaluate the outer integral. The inner integral gave us 1. So our double integral simplifies to the integral of 1 with respect to y from 1 to e. This is just y evaluated from 1 to e, which equals e minus 1. Therefore, our final answer is e minus 1. This problem demonstrates the power of changing the order of integration in a double integral. By swapping the order, we turned a potentially difficult integral into a much simpler one. This technique is especially useful when the integrand has a structure that makes it easier to integrate in one variable before the other. Remember the key steps. First, identify the region of integration. Second, express it in terms of the new integration order. Third, determine the new limits. And finally, evaluate the resulting integral.